Welcome back to the Knowledge Academy's YouTube channel. In today's video, we're delving into one of the fundamental principles of object-oriented programming using Python. Before anything else, let's see what object-oriented programming, or OOPS, is. Object-oriented programming in Python is a way of writing code that focuses on creating objects that have both data and functionality associated with them. In Python, everything is an object. These objects can represent real-world entities, such as a car, a person, or a bank account, or abstract concepts, like a mathematical function or a data structure. Classes are used to define the blueprint for creating objects. A class contains attributes and methods that define the properties and behaviors of the objects created from it. For example, imagine a class named car. Within it, we define attributes like color and speed, and methods such as accelerate and brake. This allows us to create car objects with specific colors and speeds and perform actions like speeding up and slowing down. Let's now explore the compelling reasons to invest time in mastering this paradigm. Do you know that proficiency in object-oriented programming is often evaluated in many job interviews? It's because object-oriented programming boosts efficiency, maintainability, and scalability in multiple ways. Let's examine the first aspect: efficiency. Object-oriented programming excels at breaking down intricate systems into smaller, reusable objects, fostering a modular design approach. This modularity not only streamlines development but also paves the way for faster implementation and smoother debugging processes. Let's see this with the help of some codes. First, we are creating a class named Task Manager. Then, we are defining a method called Process, which takes task as an argument. Inside the process method, we are using a print statement to display the name of the task. This simple method encapsulates the functionality of processing tasks into a single unit. By organizing functionality into manageable units like this, object-oriented programming enhances code organization and readability. This ultimately contributes to higher development efficiency and reduced time to market for software projects. Now, let's explore the next benefit: maintainability in more detail. Object-oriented programming enhances maintainability by organizing code into logical units through encapsulation, inheritance, and polymorphism, making it easier to understand and modify over time. Let's now take a closer look on how object-oriented programming contributes to scalability in software development. Object-oriented programming equips programmers with the tools to design software that can effortlessly accommodate future growth and changes. By adopting object-oriented programming principles, programmers lay the foundation for applications that can seamlessly scale to meet evolving requirements and handle increasing complexity. This approach empowers them to anticipate and address scalability challenges early in the development process, ensuring their projects remain adaptable and robust as they progress. Introduction to object-oriented programming components. Before we dive deeper into OOP, let's take a moment to understand its key components. 1. Objects and classes. Objects are instances of classes, representing real-world entities or concepts by bundling together data or attributes and actions or methods. Classes serve as blueprints for creating objects, defining their structure and behavior. Secondly, we have inheritance. Inheritance allows a new class, subclass to inherit properties and behavior from an existing class, superclass. This promotes code reuse and facilitates hierarchical relationships. Next, let's see encapsulation. Encapsulation involves bundling data and methods within a class, hiding internal details and exposing only necessary interfaces. Next, we have abstraction. Abstraction focuses on hiding complex implementation details and presenting a simplified interface to users, promoting code maintainability and readability. Finally, we have polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass, enabling flexibility in code and promoting code reuse. In this video, we'll explore objects, classes, and other foundational concepts of OOP. Alright, now that we've covered the basics, let's dive straight into the heart of object-oriented programming. First up, we have objects and classes. A class is like a blueprint for creating objects. It serves as a template or prototype from which individual objects are instantiated. Now, let's break it down a bit further. Think of a class as a recipe book. It contains instructions on how to make a specific type of dish, defining the ingredients and cooking methods. And how does this relate to objects? Well, an object is an instance of a class. It represents a real-world entity or concept by bundling together both attributes and methods. Here in this scenario, object is like the actual dish you prepare using that recipe. Each dish follows the instructions laid out in the recipe book, but may have slight variations based on factors like ingredient quality or personal preferences. So just as you can use the same recipe to make multiple dishes, you can use a class to create multiple objects with similar characteristics and behaviors. Now, let's further explore the concepts of classes and objects in Python by diving into some code. Here, we are defining a Python class named dog. This class serves as a blueprint for creating dog objects, each with its own set of characteristics and behaviors. Attributes are the characteristics or properties that define each dog object. In our dog class, we have two attributes, name and breed. Methods, on the other hand, are functions that define the behaviors or actions that a dog object can perform. Our dog class includes three methods. 1. Set details. Sets the name and breed attributes for each dog instance. 2. Bark simulates a dog barking. 3. Display details displays the name and breed of a dog instance. After creating an instance named myDog, we set its details using setDetails method. Then we interact with myDog by calling bark method and display details method. That's how you define class and methods in Python. In the above code, you might have noticed the keyword self inside methods. This self is a reference to the instance of the class. Let's see why we need self keyword. When we define methods inside a class in Python, we need a way for those methods to refer to the specific instance of the class they're working with. This is crucial because we want methods to be able to access and modify attributes specific to that instance. When you call a method on an object, like mydog.bark, Python automatically passes a special reference to that object into the method. This reference is like a secret code that tells the method, "Hey, I'm talking about this specific object here." Now, this special reference is typically called self. It's a way for the method to know which object's attributes and behaviors it's supposed to work with. So whenever you see self inside a method, it's like the method is saying, "Okay, I'm talking about this specific object now." It allows the method to access the object's attributes, modify them if needed, or even call other methods of the same object. Now, let's connect the dots between self and constructors in Python. Constructors are special methods within a class that are automatically called when a new instance of the class is created. The primary purpose of constructors is to initialize the object's state by setting initial values for its attributes. Constructors, such as the init method, serve as the entry point for initializing objects. Inside the init method, self is used to refer to the current instance of the class, enabling us to set initial values for the object's attributes based on parameters passed to the method. So think of self as the bridge that connects the blueprint of a class to the actual instances created from it, while constructors act as the architects, laying the foundation for each new object state. Let's see the use of init methods with the help of codes. In the previous code, we created a class dog to represent dogs. We had this method setDetails that allowed us to set the name and breed of the dog after creating the object. It worked fine, but there's a more convenient way to do it. Imagine you're getting a new dog. With the setDetails method, it's like getting a dog in pieces and assembling it manually, first creating a blank dog and then setting its details. But with the init method, It's like getting a fully assembled dog right from the start. When you create a new dog object, Python automatically calls the init method and passes any arguments we provide. Up on next, let's explore some practical use case for objects in Python. 1. Objects for comparison. When we have multiple objects of the same class, such as different dogs, we often need to compare them based on specific criteria. In our dog class, we introduce a compare method to facilitate this comparison. The compare method takes two dog objects as arguments: self, representing the current dog object, and other, representing the other dog object we want to compare with. Here we utilize self within the compare method to access the attributes and methods specific to the current object. This allows us to refer to self.breed within the compare method to retrieve the breed of the current dog. Inside the compare method, we check if the breed of the current dog matches the breed of the other dog. If they match, we return a message indicating that they are of the same breed. Otherwise, we return a message indicating that they are of different breeds. Now, let's try calling the method to see if we are right. We've created two dog objects, my dog named Gypsy and other dog named Charlie. Gypsy is a Labrador while Charlie is a Poodle. So when we call the compare method on my dog and pass other dog as an argument, we expect to see a message indicating that they are of different breeds. Let's run the code and see the result. It says Gypsy and Charlie are of different breeds. 2. Objects in mathematical expressions. Let's now consider a different scenario where we utilize objects in mathematical expressions. Suppose we have two objects representing rectangles and we want to calculate the total area when they're arranged side by side. In this example, we define a rectangle class with a method to calculate its area based on the length and width attributes. We then create two instances of the rectangle class with specific dimensions and calculate the total area when they're arranged side by side. Finally, we display the result as the total area of the rectangles. Three. Objects in iteration. Now, let's explore one last example of using objects in iteration before we conclude our session. In this example, the counter class illustrates the practical utility of objects in Python. By defining a class to represent a counter, we create a versatile template for managing counts. This approach promotes code organization and clarity, enabling us to manipulate counters independently within our program. Utilizing objects in Python facilitates the modeling of real-world concepts with precision. With the counter class, we can simulate physical counters and execute actions like incrementing and resetting with ease. After the first increment, the counter value should be 1. After the second increment, the counter value should be 2. We can even reset the counter back to 0. With just a few lines of code, we've created a reusable template. Objects foster modular and reusable code, enhancing maintainability and scalability, while offering an intuitive means to represent and manipulate data and behavior. That wraps up our discussion for today's video on object-oriented programming using Python. We've covered the fundamental concepts of object-oriented programming, including how to define classes, create objects, and use methods to manipulate data. By understanding these concepts, you've taken your first steps into the world of programming, equipped with the knowledge to create reusable and organized code using object-oriented programming principle. In the next part of our series, we'll delve deeper into advanced loop topics, exploring inheritance, polymorphism, and more. If you enjoyed this video, hit the like button and subscribe to our channel for more exciting and informative content. Don't forget to turn on notifications so you never miss an update.